a by 2 and pi by 3 angle. Okay, and it is 120 degree. It is a by 2, so 3a by 2, 3a by 2 value of r and 2 pi by 3. It is here pi and 2a and pi at this point, etc. This is the plotting of this curve. If I take this as y-axis and this is axis here, so this is symmetric to the initial line. OA is the initial. Let me take A here. OA is the initial line here. This curve is symmetric to the initial line OA. You see here, it is symmetric to the initial line. It is plus A here. Then we increase the angles. We will get the same up to 2 pi. Okay, up to 2 pi. At 2 pi it is 0 here. So it is plus 1. It will be plus 1 here, so 1 minus 1, 0 at 0. So 0 at 2 pi it will come here. Again the same figure. So this is symmetric figure to the initial line. This is first question. This is how we have to plot these questions here. And no symmetric, no asymptotes here. No asymptotes. No asymptotes here. Okay. And the curve is symmetric to the initial line. Curve is symmetric about the initial line. This we already clarified about the initial line. This we have just put here. So this is symmetric about initial line. Okay, so that is the question number 1 has been plotted like this. This is the figure for plotting of the question number 1 curve. Okay, so this is question number 1 we have taken here. Now let me talk about second question. Now question number 2. What is second? Okay. Now if we talk about the other points, I mean questions here, let me take those questions. Those questions are okay. Marker. Okay, so question number now second. Let me discuss about question number 2. Change. Okay, let me change it. Question number 2. What is second question? Here second question says, okay, plot the curve R is equal to, or trace the curve R is equal to A into, now it is 1 plus cos theta. Again, solution. Okay. First point, this is symmetric to, sorry, if I take, let me describe it first. If we replace theta by minus theta, the curve does not change, or it remains unchanged. The curve does not change. The curve does not change. Hence, this curve is symmetric. This curve is symmetric about the initial line. Symmetric about the initial line. Okay, second point. Then what are the different values of this point? Let me find out. Okay, so this is symmetric about initial line. One thing. Secondly, if R is equal to theta, sorry, R equal to 0, if I take, putting R equal to 0, putting r equal to 0. Okay, so cos theta is implies that 1 plus cos theta is equal to 0. Yeah, 1 plus cos theta is equal to 0. That means cos theta is equal to minus 1, which is cos pi. Minus 1 here. Cos theta equal to minus 1 or theta equal to pi in this case. When r equal to 0, theta is pi. Okay. Now let me take the different values for this. Other than different values, at pi, as we increase from pi, the value will come out as minus 1, it is 0. But theta at pi it is 0, value is. Okay, and if I take next point, let me plot the other values. So theta, let me start from pi here, theta equal to pi. Okay, pi here, r equal to 0 at pi. Then we let me take 120 degree, or let me take from the beginning, no problem. If it is 0 here, theta is 0, for instance. Cos 0 is 1, so it is 1 plus 1, 2. R will be 2 if I take. Then if R is pi by 3 angle again, so it will be 1.2. 1.2. It is 2 by 3 by 2. 1.5. 3 by 2, so it is 2a by 3. R is 2a by 3. Okay. But it's pi by 2, 90 degree. The 0, it will be a only. Okay, if it is pi by 2 pi by 3, it is then minus half. Minus half is half only, which is a by 2. It is a by 2 here. Okay, with minus half. Then 1 pi here, let me take now. Not 150, let me take pi. So at pi it is minus 1, which is 0. So what we have taken, at pi it is 0. So with the r we have to increase. That means 0 at pi it is 0. We have to start from the beginning. Okay, so from in this case the curve will be, let me plot the curve. What curve will be here? This is initial line or OA, let me take. From OA at pi degree, it is pi here. At pi it is 0, r is 0. This is the point at pi angle. Then at pi by 20, this is a by 2, then this is a by 2. It will come out as like this. This is the figure just opposite of the first one. Okay, now let me take those points here. And here it is A, this point is A and pi by 2, theta pi by 2, and R is A. Here the point was this one, A by 2 and 2 pi by 3, this angle, and at 60 degree, if you take here, it is pi by 3. Angle is, and this is 2a by 3. First let me write the point. R value is 2a by 3 and it is pi by 3 angle. At 0 it is A, sorry, twice A. It will be twice A. 0 it is twice A. At this point it is twice A and 0. Twice it is, distance is twice A from initial point to this point. Okay, at this point it is A, we can take all this distance A here. Simple, this twice A. So this is the origin O. Origin or pole here we have taken. This is y-axis, y dash. We can take the Cartesian coordinate, no problem. This is initial line which is along the x-axis, and this is the line which is perpendicular to the initial line at pi by 2 degree angle is line. So it's A and pi by 2. This point is here A, distance is A along this line. We have taken this A and pi by 2 point. This is plotting of the second question. It is again symmetric to the initial line, which we just clarified here. Theta replacing by minus theta, so there is no change in the curve. The curve will be symmetric to the initial line, which is symmetric here. This kind of curve will be obtained. So we just tabulate the values of r and theta, and then they are plotted. We can find out. Here also no asymptote. Here no asymptote here. No asymptote is possible because this is a closed figure. What is no asymptotes here? Now, third question number third. Let me take three questions. Question number 3 here. Question number 3 or third question. Let me take. What does it say? Now here we are given exponential function. Exponential function. Okay. Here, question number 3. We have the curve r is equal to a theta. Okay. So this is not symmetric to any initial line because theta is replaced minus theta, no change. It's not symmetric to any initial line or pole, nothing. It is symmetric. But if theta is replaced by minus theta, no change, it will change, it will change, so it is not initial line. So no symmetry. Let me take solution. No symmetric here, so it is not a symmetric function. It is not symmetric. It is not symmetric to initial line or pole. It is not symmetric. But for pole, we have to take this value is not to be changed. It will be replaced r by minus r. So, but it will change. It will not remain. So it is not symmetric to initial line. Sorry, or pole. Initial line or pole. Okay. One thing is not symmetric. So if I find out different values, let me find out what are the different values of this. So if I take r is equal to infinity or theta, let me take first theta tends to infinity. Theta tends to infinity, r also tends to infinity. R tends to infinity. Theta tends to minus infinity. R also tends to minus infinity. Sorry, R tends to plus infinity here. R will tend to plus infinity. This is the position here. And then other values can be taken out. If R is pi or any angle, theta if is angle. So table, let me write here table of values. If I take theta 0 degree, theta 0 degree, then what is r here at 0 degree? Then let me take pi by 3, and pi by 2 pi by 3, 4 pi by 3, 2 pi by 3 is 4 pi by 2 pi by 3, 4 pi by 6. It is not to take this 150 degree, sorry, not to take 150 degree, 6 pi by 5, no, pi by 3, 2 pi by 2, or we can say pi by 6 also, 2 pi by 3, then pi, etc. For the plotting, and then infinity also we can take, because r tends to infinity and infinity. So there will be the curve will be symmetric to what? I mean, there will be a tangent line which will meet it at infinity. So r is equal to, at 0 it is to a only, because e raised power 0, theta is 0, it is 1, so a r equal to a. Then it is a e raised power a pi by 3a. Then this is a into e raised power pi by 2a. Okay. And e raised power a into 2 pi by 3. And then ae, sorry, this is a, what I'm writing here, a into e into a theta. This is ae. Okay, this is a into e pi theta, pi a only, etc. Okay, so the value of these if calculated, and then they are plotted. Let me plot that figure here. That theta pi by 2. So this is the initial line. Oh, let me take x axis, this is y axis. At this theta equal to pi by 2. What is the curve here? So this curve, if I start from this point, in this way it will start. Okay, this is how the curve is of this kind in case of this. So the plotting of this figure is in this way. Okay, and here theta is equal to 3 pi by 2, 270 degree. This pi here. Theta equal to pi at this point. Here theta pi by 2. Here theta equal to 0. At the initial line, theta 0, theta pi by 2. In between it is theta equal to pi by, or just write only four values. No need of this writing. In this way, this curve will be of this kind. Okay, so this is what we have taken. Only there are only 3 curves here. If I take only 3 values, it will be only this. Okay, only 1, 2. This is 1 and 2. Only 1 and 2. Okay. So this is how we have plotted this figure. The plotting of this figure will be of this. So question number 3 is an exponential function. Exponential function is, if I just put the value of exponential, this e, then power of this calculated, this kind of figure will be obtained here. Okay, so this is how we have plotted this figure. Question number 3 is done. So this is the curve. Question number 3 is exponential curve. So this we have plotted in this way. Now let me talk about question number 4. Fourth is again very interesting question. Okay. Question number 4 is r theta equal to a. Here r, okay, fourth question. Here r theta is equal to a. Or if I write it as, or here theta and r both are replaced as minus theta minus r, then this curve will be symmetric too. But if theta is replaced by minus theta and both r is also replaced with minus r, then it is not changed. Solution: if theta is replaced by minus theta and r by minus r, both things, the curve will be symmetric to both initial line as well as the pole. So no change by r, the curve will not change. The curve will not change. Equation of the curve will not change. Equation of the curve will not change. Hence, this curve will be symmetric. Hence, the curve will be symmetric. Curve will be symmetric, or curve is symmetric about pole and the initial line and the initial line, both the things, and the initial line. Okay, second point, this is first point. Second point, if I solve it for r equal to a upon theta, what is it? If theta tends to 0, r tends to infinity. So as theta tends to 0, r tends to infinity 1. And if r tends to infinity, theta tends to 0. And if theta tends to infinity, r tends to 0. Both the possibilities are there. Okay, so this is one of the points here. Now if I change it, okay, this is r equal to a upon theta. So if I find out different values, let me find out theta pi by 2 and 2, so 2 upon pi and this and that. This will be infinity type of curve. Okay, and if I just replace this value, because r equal to, this is r theta, sorry, this is r theta is equal to a. Okay, so if I put r equal to r a sin theta, then okay, so r is if I put here r equal to a by theta, or r equal to that point. I'm just thinking about something, how y equal to r sin theta. If I put r sin theta, and r sin theta is equal to a here, the quantities are equal to theta we have taken. R sin theta is equal to a. If I take y equal to a, changing this into Cartesian coordinates. If I change this into Cartesian coordinates, then what is the point here? The equation is, okay, so this is, the curve is symmetric about the initial line. Okay, and second point is a from theta we have taken. Okay, so this is known as hyperbolic. What is that? It is the hyperbolic spiral. Okay, this is hyperbolic spiral type of. If I put r sin theta is equal to a, that means this is y here. Y is equal to a. Okay, if I put here, if I change this into Cartesian coordinates, then r sin theta is equal to a. This is r theta only. So r sin theta, if I put, then y is equal to a. So y is equal to a. That means this is the curve here. Let me draw the curve here. So this is origin O or pole. This is the x-axis. Let me take this y-axis and at angle theta. Now here it is y equal to a. This is the line at which y equal to a here. Okay, this is asymptotes here. So if I take okay, so this is as theta tends to 0, y tends to infinity. Sorry, r tends to infinity. So this is the spiral term. Now again, if I take this point, I'm sorry, this is here. Okay, so this kind of curve will be there. So this is spiral known as hyperbolic spiral. Why this is here at the line y equal to a, it is a asymptote here. y equal to a is an asymptote. Y equal to a is an asymptote of this curve, then asymptote. Changing this into Cartesian coordinates, so we have changed this r sin theta equal to a or r sin theta is y. Okay, so this is the value here. Y equal to a, Cartesian coordinates. Alright, so Cartesian coordinates, we have converted this into r sin theta is y, we consider r cos theta is x, but here it is y. Y equal to a is the asymptote for this equation, so that theta tends to 0, r tends to infinity, whereas theta tends to 0 here, so r tends to infinity, okay, positive infinity here, and r tends to 0. When r tends to 0 here, then this tends to infinity. Okay, so theta tends to, in both the cases, in negative value also, when r tends to, when theta tends to minus infinity, r tends to 0 again. But theta tends to minus infinity if I take this side, b infinity, y tends to positive infinity. Sorry, theta tends to positive infinity. So r tends to infinity, or theta if I take here, theta 0, y 0, r 0, theta infinity. In this way, or theta tends to, in both the cases, positive, because r is always positive value, theta tends to infinity. And similarly, if r is infinity, then theta is 0, or r is theta infinity, then r is 0. Okay, so this is the known as spiral, hyperbolic spiral curve. This is the shape of the curve. This is hyperbolic spiral curve. Theta tends to 0, r tends to infinity on this. Okay, or r theta equal to a we are given here. So if I convert this into Cartesian coordinates, then r sin theta is equal to a, we know about, y is equal to, this is r sin theta is y here, y is equal to this value. Okay, if I multiply this y, this r sin theta. Okay, so this is known as hyperbolic spiral point. Okay, this curve is of this shape. Now let me take the spiral of Archimedes. Fifth question. So the spiral of Archimedes, that is also similar type. This kind of question is also there. Now this was symmetric to both pole and initial line. This question was okay, symmetric to both. Again, the similar type of question is there. This is known as Archimedes spiral, the spiral of Archimedes. Question number 50 here. Here we are having r equal to a theta. R equal to, this is a spiral of Archimedes. Again, in this case also, okay, if I take, so this is symmetric again, so let me take symmetry of this curve here. If I replace, if r is replaced, r and theta, let me take r is replaced by minus r and theta by minus theta, no change, then the curve does not change, then the curve remains unchanged. The curve remains unchanged. Curve remains unchanged. Okay, in that situation, it means the curve is symmetric to both pole and initial line. Hence the curve is symmetric. Hence the curve is symmetric about both the pole and the initial line. So this is symmetric to both pole and initial line. Now let me find out some values. Okay. So again, when r tends to, theta tends to infinity, r tends to infinity. Theta tends to 0, r tends to 0. Theta tends to minus infinity, r tends to minus infinity, and so on. This is what we have to talk about if r is equal to second point. r tends to infinity implies that theta tends to infinity. Simple. R tends to minus infinity. Theta also tends to. This implies that theta also tends to minus infinity. Because this is direct relations. So this is, it means asymptote should be there. What is the asymptote here? And let me find out different other values. If theta is replaced by 0 or 0, okay, then theta is pi by 2. Then it is also pi a by 2. And if it is pi by 3, pi a by 3, etc. etc. So those values, let me find out the table here. So the table will give us different values. If I take at pi by 2, it is, if theta is equal to pi by 2, then it is pi a by 2. Okay, that value is there. So at theta is equal to pi by 2, so that point is to be replaced by us. Okay, so in this case also the curve will be of this kind. Okay, and this will be, I'm sorry, this curve will be of this kind. This is the curve of this kind here. No, this is x-axis, origin, this is y-axis. Here theta equal to pi by 2. Here theta equal to 0. Then theta equal to pi. Okay, so if these values are plotted, a into pi by 2, pi suppose 3 1 by pi is equal to here 3.1416. If I put this value, then a into this value is to be converted. And from this to this point at theta pi by 2, it is r is equal to a into pi by 2. Pi is 3.14. This value will be this kind. Okay, so this kind, this is the plotting of, this is known as Archimedes spiral or spiral of Archimedes. This is Archimedes spiral. Okay, so this we have taken here, Archimedes spiral.